Hi, my name is Lucas Chan. Welcome to another chemistry video of mine. So today we're going to be speaking about the nucleophilic addition elimination mechanism seen in acyl chloride. Now remember, we have actually done acyl chloride back then, sometimes a few months ago. And so now what happened now is that we will actually look at specifically the addition elimination mechanism of acyl chloride, but the structure is actually given right over here. But the R group is actually represented by the alkyl group. So we're going to be seeing the reactions of acyl chloride, right, undergoing the addition-elimination reaction with water. We're also going to be seeing the reaction of acyl chloride with the alcohol, and we're going to see them reacting with ammonia and the primary amine. Now, in our examples today, we're going to be using the ethyl chloride. This is basically the ethyl chloride molecule at the bottom here, whereby there's actually two carbons, the first carbon being right over here, and another carbon is actually the CH3 carbon. So therefore, this is actually called the ethyl chloride. So let's get straight into it. Let's look at the first reaction, whereby we're going to be speaking about the hydrolysis reaction of acyl chloride, right? So the reagent is, as indicated over there, is the water molecule. The condition, it can be done in the room temperature. And remember, this reaction is actually very, very vigorous. It releases a lot of heat. And the product over here is actually, of course, none other than the carboxylic acid itself. So the equation is actually given right at the bottom over there, whereby you have ethyl chloride reacting with water. This is actually called the hydrolysis reaction to produce the carboxylic acid and the steamy white film of the hydrogen chloride. Now, the reaction may be called as the hydrolysis reaction, but if they ask you what is the mechanism behind this reaction, as a student, you need to basically be able to tell that this is actually going to be done via a nucleophilic addition-elimination reaction. So let's look straight into the mechanism here. Now, in addition-elimination reaction, just like the name, right, itself, is basically a two-part process here in this particular mechanism, whereby it's always starting with the addition reaction, right? So the nucleophile, in this case, would be the water molecule right at the bottom, as you notice over here, will act as a nucleophile to actually trigger off the reaction. Now, before we actually start, we actually need to actually draw out the molecule of the ethyl chloride first, the acyl chloride. And the first thing that we should do is, of course, labeling the delta positive carbon and the oxygen being delta negative over here. So the next thing that you need to do is that, of course, make sure your nucleophile is situated right at the bottom, like how I indicated here. And what happened now is that you're going to need your nucleophile to trigger off the reaction, whereby the lone pair of electron, right? The lone pair of electron from the water molecule, specifically on the oxygen, the lone pair of electrons from the oxygen will basically be attacking the carbon delta positive. So remember, this is actually the first arrow that you need to actually indicate in your mechanism. Remember, the reaction is triggered off by the nucleophile. So in this case, the nucleophile, remember, is the water molecule. So the lone pair of electron from the oxygen will actually what they call this, be directed towards the carbon delta positive. Now, if this process actually happens, you're going to actually form 5 bonds around the carbon. Because existing around the carbon, you already have the 4 bonds. And remember, carbon can only form maximum of 4 bonds, am I right? So therefore, if this oxygen is about to form a bond with the carbon, that is actually not going to be happening, right? So you need to actually have to break one particular bond. The one bond that will be broken over here is the carbon to oxygen bond. Remember, I repeat again, the carbon to oxygen bond will be broken up. It will actually make way, right, in order for this carbon to oxygen bond to actually form. Now remember, once the pi bond of the C double bond O is actually broken, you are actually going to get an intermediate that looks like this. Now this is an intermediate over here. Now bear in mind, right, oxygen right at the bottom over here is positively charged because they have actually used up its electron, one of its electron, to be shared with this particular carbon right in the middle. So that's why the oxygen here is positively charged. And the oxygen right above here, right, is actually negatively charged because they have actually received the electrons when the heterolytic fission takes place, when the pi bond breaks in that process of the reaction. So remember, this is the addition part of the mechanism. Now remember, this is not done yet because this is actually literally your intermediate right? So we're going to move on next to the next part of the reaction, whereby we'll see an elimination reaction. Now, you should know that by now that the small molecule will be released over here in the form of hydrogen chloride will actually take place. So let's go straight into this intermediate that we had just now. Now, this particular elimination reaction begins when the lone pair of electron that from the oxygen with the negative charge over here will be contributed back to the carbon double bond to actually form carbon double bond O over here. So remember, this lone pair of electron from this oxygen, right, will actually be making back the C double bond O. Right, so this is actually what is expected to happen. Now remember, again, like what I mentioned just now, if you are to form a double bond between this carbon and the oxygen again, the carbon can only actually make 4 bonds around them. So if you want to make the pi bond back, okay, on this particular C double bond O, 1 bond has to be broken, and that 1 bond that needs to be broken is the carbon to chlorine bond. So once you actually do this particular process over here, you are actually going to start to see the C double bond O to be reproduced back right on this particular side over here. Now bear in mind, your water molecule actually still existing as what they call this section over here, whereby you have oxygen with a positive charge. Now the reaction is not done yet until you remove the hydrogen from the molecule that you're seeing right on this particular right hand side. So what you're going to do next is that, remember, once the chloride ion is actually produced from this particular heterolytic fusion between the carbon-chlorine bond, the free chloride ion now will actually withdraws away the hydrogen from the intermediate that you see on this particular side. So what you're going to be seeing is that, remember, now this oxygen to hydrogen bond will be broken. Both electrons will be passed down back to oxygen to make sure that the lone pair of oxygen is being restored back. And in that sense, you're going to be getting your final product, which is actually your carboxylic acid, and it's actually going to be releasing the small molecule in the form of HCl. So remember, this is the elimination part of the reaction, right? So elimination part of the reaction, right, will actually allows you to form back the C double bond O. Right? At the same time, you remember you have to actually break off the C to Cl bond, right? And the CS chloride ion that is actually released will actually withdraws the hydrogen, right, from the nucleophile that was used earlier in order for you to produce the final product, which is the carboxylic acid, and the small molecule that is released here through elimination reaction is the hydrogen chloride. So the hydrogen chloride is going to be removed as a gas. Okay, so this is the reaction, right, with the water. The next one we're going to see is that we're going to see our acyl chloride, particularly the ethanol chloride, reacting with the ethanol. So in this particular reaction over here, you are going to be producing none other than the ester. And of course, the small molecule that's eliminated or released over here is actually the hydrogen chloride. So you could actually use a phenol as well, just like what I indicated in the equation. Phenol actually reacts with the acyl chloride as well. This will actually allow you to produce the phenate esters, as you can see on the right hand side here. And also the steamy white film HCl is released. Now, as you're aware, esters are sweet smelling liquid. Now, this reaction can be carried out at just room temperature, but you have to make sure that there is a solvent of the aqueous sodium hydroxide being used in this particular reaction. So in the mechanism, okay, which I'm going to show you in a short while, we're going to be specifically looking at the reaction of ethanol chloride with the ethanol. So let's get straight into it. Now, the reaction, of course, starts again with the addition reaction. This time, the nucleophile is actually going to be the ethanol. The ethanol molecule contains the oxygen atom. The oxygen atoms contains a lone pair of electron, which is actually going to be attacking the carbon delta positive. But remember, as we mentioned earlier just now, before we actually draw any arrows, the first thing you must do is to put up the delta positive and the delta negative on the carbon, right, and the oxygen. So then you're going to need to now draw up your arrows. Remember, the first arrow, okay, which actually starts off the reaction is basically, right, the arrow that is actually coming from none other than the nucleophile, okay. This lone pair of electron from the nucleophile will basically be attacking the carbon delta positive. This will actually make the carbon to oxygen bond, which we're going to see later on the product side. So remember, when this carbon to oxygen bond is needed to be formed over here, right? Carbon can only form maximum 4 bonds. So one bond has to actually make way. The one bond that actually has to make way is the pi bond between the carbon to oxygen bond. So this bond has to be broken up. And as a result of it, you are actually going to get an intermediate that looks like this. I already explained just now, right? The oxygen over here from the nucleophile will be positively charged because it has actually used up its electron to form a bond with the carbon in the middle over here. And this oxygen right up here is negatively charged because remember, the pi bond actually breaks. Both electrons actually given to this particular oxygen. So that's why oxygen is actually having the negative charge over here right now. So reaction is not over yet because remember, there's 2 parts to the reaction, right? The next part is the elimination reaction, whereby the HCl molecule needs to be eliminated from this particular intermediate. Just like just now, right? You're going to actually see the double bond, the C double bond O, to be redeveloped back. They're going to actually reform back by actually doing this, right? The lone pair electron from the oxygen will be contributed back, right, to the carbon to oxygen bond, making back the pi bond. And at the same time, the carbon-chlorine bond needs to be broken up, right? Because remember, if the pi bond is to be reproduced, you need to make sure that the carbon basically have only 4 bonds all the time. 1 bond therefore needs to be broken. So therefore, the carbon-chlorine bond will be broken this time, right? In order for you to actually get this particular product, right? Remember, it's not over yet again because you need to ultimately remove the hydrogen chloride molecule. So the free chloride ion that is actually produced right at the bottom over here will actually be used to actually attack the hydrogen, right, from this molecule that you see on the right hand side. And the hydrogen to oxygen bond will be broken heterolytically. Both electrons will be returned back to the oxygen, right? This will actually allow you to yield the ester, and also the small molecule of hydrogen chloride is being reproduced here. That's basically the reaction, the esterification reaction between your acyl chloride just now, ethanol chloride, with the what they call this, the ethanol. But ethanol over here played the role as the nucleophile in the addition reaction. And what you're seeing on this particular slide is the elimination reaction, whereby the ester and the hydrogen chloride is being reproduced. Okay, we're going to move on next to another reaction over here. This is another reaction of acyl chloride, another very vigorous reactive reaction as well, like the previous 2, right? You're going to have the reagent here is none other than what is indicated there, ammonia. Reaction can be carried out at room temperature. Now, this is excellent to produce amides. Now, amides is basically this particular molecule that you see on the right-hand side here, whereby the NH2 group is bonded to the C double bond O. Now, as usual, the hydrogen chloride will be actually released as the hydrogen chloride molecule on the right-hand side here. Now, let's look at the mechanism once again. It starts again as with the addition reaction, right? Remember to actually put up the carbon delta positive and the oxygen delta negative. This time, our nucleophile will be the ammonia molecule that is actually right at the bottom there. So what happened now is that, remember, ammonia, which has the nitrogen atom that contains 1 lone pair of electron, this nitrogen with a lone pair of electron will act as a nucleophile for this particular reaction. So it starts off with the nucleophile attacking the carbon delta positive, just like the previous 2, right, as well. And then what happened now is that once you want to make carbon to nitrogen bond, you have to actually sacrifice the bond. The bond that you have to actually make way or to break is the pi bond between the C to oxygen bond. So this bond will be broken up. You are actually going to get this particular intermediate. So remember again, please put again over here the nitrogen here to have the positive charge, and the oxygen right above is negatively charged. So this intermediate will participate in the next stage of the reaction, whereby you see an elimination reaction of a small molecule will be removed. In this case, it will be the HCl once again will be removed. So what happened now is that in the elimination reaction, remember, you need to redevelop back, you need to reform back the C double bond O. You need to actually form back the pi bond between the carbon and the oxygen. So as such, the lone pair of electron from the oxygen over here will be contributed back to the C, the format, or what will be contributed back to the C to O bond to making, this will actually make the pi bond, right? This will actually cause you to also need to break the carbon to chlorine bond. Because remember, if you want to make the double bond, the C double bond O back, you would actually have 5 bonds over there. You can't actually have 5 bonds. Therefore, one bond has to be broken up. The carbon-chlorine bond will be broken, and in that process, you are actually going to get this particular structure. It's not over yet, as we all know, because the chloride ion will then actually be attacking the hydrogen, which is actually, this is to remove them as the hydrogen chloride, and this will actually followed up by the breaking up of the nitrogen to hydrogen bond. This will allow you to get the final product, which is actually your amide. Okay, this is the ethanamide that is actually produced over here because it's 2 carbon. And of course, you release a small molecule, which is the hydrogen chloride molecule is released as a byproduct. So this is actually a reaction over here. What is different here is just that nucleophile. So as you notice, right, they're all the same, right? It's just that we're using different nucleophiles in this reactions of acyl chloride, let it be water with alcohol, or now it's actually with ammonia. So basically, it's addition reaction followed by elimination reaction. Let's move on to the last one over here. This is the reaction of our acyl chloride, our ethanol chloride reacting with a primary amine. So primary amine, as you can see over here, is basically where you have your amine and the nitrogen. You basically have only one alkyl group attached to it. So condition here is that you can actually do this reaction at room temperature. You are actually going to be producing the N-substituted amides over here. So in this case, your NH group over here is actually bonded to the C double bond O, and at the same time the NH group is also bonded to an alkyl group. So that's why I call it the N-ethyl ethanamide, right? And of course, a small molecule of HCl is actually produced. Remember, this reaction is also very, very vigorous because of the acyl chloride being very reactive here, right? Very reactive here. Let's move on again. Now we're going to look at the mechanism, right? In terms of the mechanism, it's starting off with the addition reaction. Just like just now, you start off with labeling the delta positive and the delta negative on the carbon and the oxygen. And then right at the bottom, I have actually drawn up this particular structure over here. This is your amine, right? That what they call this, the amine that's actually containing 2 carbons, the primary amine, like what we described just now. So again, on the nitrogen, you got the lone pair of electron. So this lone pair of electron on nitrogen will serve as a nucleophile for this particular reaction. So what you're going to see is that the lone pair of electron from the nitrogen will basically trigger off the reaction. Okay, you're going to see the lone pair of electron here on this nitrogen attacking the carbon delta positive. And then, of course, you can't make 5 bonds around the carbon. So therefore, the pi bond will be broken, right? Just like this. This will actually allow you to get this particular intermediate. Remember, the nitrogen now it's positively charged because it used up this electron to form this particular bond. And the oxygen right above, it's negatively charged because remember, the pi bond is broken, electrons has been contributed to the oxygen. So the oxygen got extra electrons now, that's why it's negatively charged. Okay, so move on to the next elimination reaction part, whereby the HCl is removed. So what happened is that, right, in the elimination reaction, it starts off with the lone pair of electron from the oxygen with a negative charge over here will be used to produce back the C double bond O. So the lone pair of electron here will be actually contributing back to the formation of the C double bond O. And remember, if the C double bond O are to be reproduced, the carbon-chlorine bond will actually needs to actually be broken up heterolytically. So this is actually going to be the 2 arrows required for you to actually indicate in this process. Of course, you're going to get this is not the final product yet. You're going to need to still remove the hydrogen chloride. The chloride ion that is released will actually do the job to actually extract out the hydrogen from here. And so therefore, nitrogen to hydrogen bond will also break the electron, okay, from the nitrogen to hydrogen bond will actually be returned back to the nitrogen, restoring back the lone pair of electron that needs to be present on the nitrogen. So there you have it. You're going to be producing your N-ethyl ethanamide, okay, which is actually the product produced on the product side, and you're going to also be getting the hydrogen chloride, which is actually a byproduct for this particular reaction. So the hydrogen chloride is actually a gas which will escape through the atmosphere, right? Because I have to mention this because some students actually ask me, don't the HCl and also the amide actually react with one another? Chances are that there's very low possibility that they will react because HCl is going to be removed as a gas, as a hydrogen chloride. So there you have it. So that's the addition-elimination mechanism reaction seen in the acyl chloride reacting with 4 different reagents I showed you just now. The beginning I showed you with water. And then we actually did the reaction of acyl chloride with the alcohol. And we actually did also reactions of what they call acyl chloride with the ammonia. And finally, with the primary amine. So if you made it this far, thank you very much for your attention, right? I hope this actually helps you in your revision. So please make sure to try practice drawing this addition-elimination mechanism yourself. So if you enjoyed this particular video, right, please remember to actually give it a thumbs up. Please drop a like, right, by clicking that just like button over there. And if you have not subscribed, please subscribe to the channel. Right? Thank you very much. I'll see you in the next one. Bye.